Hi everyone, welcome to the holiday revision session. Today we are going to be going over Unit 3 for further maths. This is the 2019 VCAR exam number 1, which is the multiple choice exam. I have the questions here on my whiteboard behind me. I'm going to scribble all over it and we're going to talk about the answers. If at any time you have a question, please put it into the chat and we will address it. So, first things first, the histogram shown has a distribution of 48 countries in 2018. Question 1 says the number of these countries with a population size between 5 and 20 million is what? So, first things first, looking at our scale. The scale is in lots of tens with a halfway marker. That halfway marker means 5. That means that from here to here is what we care about. There are 11 here, there are 4 here, and there are 2 here. That means the answer is 17. As we go, I will be quoting particular numbers from the examiner's report. We'll tell you how many people got that question right. And in this case, 92% of people got that one right. Question 2. The histogram is best described. So we'll need to look at our histogram again. The histogram is best described as positively skewed with no outliers, negatively skewed with no outliers, positive with or positive without. So I would instantly be looking at this going, that's an outlier. So whatever we decide, it needs to have outliers. So it clearly can't be A, it can't be symmetrical, and it can't be D, because there's clearly an outlier. So if we look at the general shape, the shape looks like that, which means that that shape is plus VE, so therefore it is B. And 86% of people got that one right as well. So what they've now done is they have taken the histogram and they've turned it into a log 10 scale chart. Based on this histogram, the number of countries with a population less than 100,000 people. So, because this is a log scale, log 10, which of these log 10 numbers represents 100,000 people? So what is log 10 of 100,000? So even if you don't have that memorized, your CAS can just do it. So if we go to keyboard, Math 1, third row, fourth column, and we just type in, it's 5. So 5 is here. That means that it is whatever is here. So there looks to be 7 there and 1 there. So that means the answer is D. And 71% of people got that one right. So we're starting to get to the point where people are making mistakes because they don't know a particular thing. All right. Stem and leaf plot shows below the mathematic test scores for a class of 23 students. Seems appropriate. We've got a key and we've got an N number. The N is the number of students in the stem and leaf plot. The key 4-2 means 42. For this class, the range. All right, remember, range is highest minus lowest. So in this case here, that's my highest, that's my lowest. So what does that 9 mean? Well, according to the key, it's 8-9. So that's 89. And that one there is 4-0, which is 40. So the answer is 49. 96% of people got that one right. So, for this class, the interquartile range of the test scores is what? All right. So, I think the quickest way to do this might be to turn this into a CAS. So let's do it on the CAS. So, well, first things first, I'm just going to clear up my little markings so that I can actually read the numbers properly. So the statistics, 40, 41, 44, 44. All right. So I've entered all my numbers in, and I'm down to row 23. Now, on the actual thing there, said n is 23. See? So therefore, I know I've got the right number of numbers in here. Calc one variable, and it brings up this. So I've got here Q3, 75, Q1, 57. And so what is 75? What is 75 minus 57? Well, that's 18. Now, remember, there is other ways that you could have gone about doing it without entering it into the calculator. My calculator is on screen. You need to watch it in full screen. If you have my window shrunk, you can't see it.
Sir, we pinned you, but we still can't see the calculator. It's in half. Yeah, move it a bit.
Yeah, I can't move it over too much, otherwise it crosses over. Yeah, change the layout to spotlight. Thank you. There are a couple of other ways to fiddle with it, but again, everything is on the recording. Don't stress. I will scoot over a little bit. All right. Now, the other way you could have gone about this question without having to delve into your CAS, there are 23 pieces of data. That means that if we can quickly find where our median is, so that means our median is going to be at number 12, because the median number is at n plus 1 over 2. So that is 23 plus 1, which is 24, which is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now that we have that 12th number, we look at halfway to the top and halfway to the bottom. There should be 11 numbers on both sides. And then 11 plus 1 is 12. 12 divided by 2 is 6. 1, 2, 3, 4, 5, 6, 57. And 1, 2, 3, 4, 5, 6 is 75, which is where we got those two numbers from. The time taken to travel between two regional cities is approximately normally distributed with a mean of 70 and a standard deviation of 2. All right, so this is a standard deviation question, which means that we are working with this lovely shape here. If we have a mean here, if I go 1 standard deviation either side, how much is in there? All right, think right back to the start of the year. All right, thank you. So this is the 68, 95, 99.7 rule. So whenever we're dealing with standard deviation, those are the 3 numbers that you need to have in your mind straight away. Now, the percentage of travel times. So hang on, first things first. A mean of 70 and a standard deviation of 2. So mean of 70. If I say this is 1 standard deviation, I've gone down to 68. I've gone up to 72. But then, if I keep going to a second standard deviation, that's 66. And that is 74. Now, 1 standard deviation is 68. 2 standard deviations is 95. But if you look at the question very carefully, it says the percentage of travel times that are between 66 and, oh, it's underneath there, but it's 72. Okay, 72. That's not a full amount of standard deviations. That means it wants from here to here plus that little bit there. Now, because of that, we don't need to do any further calculations. We don't need to work it because we can automatically cross out a whole bunch. All right. It can't be 2.5 because it clearly covers more than a single standard deviation from the center. It's clearly not 34 because this here is 34. 68 would be a standard deviation either side, and 95 would be 2 standard deviations either side, which it clearly isn't. Therefore, the only answer that makes sense is D. No maths, well, a little bit of maths, but it's applying your knowledge in such a way that you don't need to break out a calculator. You can just eliminate the obviously wrong answers. And that question is a perfect example of that, because when you're talking about standard deviation and you're talking about percentages, we are going to stick to the 68, 95, 99.7 rule and the boundaries within that. Question 7. A volume of a cup of soup served by a machine is normally distributed. So again, normally distributed. We are back with this stuff again. Normally distributed with a mean of 240 and a standard deviation of 5 mils. So, again, let's quickly put our curve on the page. Our mean is 240. 1 standard deviation is 235. 2 standard deviations is 230. Now, what we have to remember with this question is that they are mostly focusing on the bottom half, which means that I can ignore the top half. But remember, because it's a standard deviation, 50% is on the bottom half. So if I was to split and divide all of this information up, I have 34% here. I have whatever, 13.5 in there. And then I have 2.5 outside 2 standard deviations. And it mirrors on the other side to add up to 100. So in this case here, the number of cups expected to contain less than 230 mils. 230 mils, well, we marked this out. We marked it out. It is 2 standard deviations below the mean. That means that anything that is less than 230 is going to be in this 2.5% area. So now we can go back and look at the rest of the question. A fast food store uses this machine to serve 160 cups of soup. What is 2.5% of 160? All right, 2.5% of 160. So 2.5 over 100 is 2.5%, times by 160, 4. Done. Percy conducts a survey of people at his workplace. He constructed a two-way frequency table involving 2 variables. One of the variables was attitude towards shorter working days, for or against. The other variable could have been what? The other variable could have been, right, a two-way frequency table. Two-way frequency table generally means that you need to split it into 2 categories. Which of those has 2 categories? It's B again. They seem to like B a lot. Because they've done it 4 times already out of 8 questions. All right. A two-way frequency table would look, almost like it could also be like a stem and leaf plot as well, where you've got the number of men and the number of women. But anyway, 2 ways. That's the only one that's in 2. Everything else is continuous data, not categorical. Two-way frequency table requires categorical. Question 9. A least squares regression line is used to model the relationship between the average temperature and the latitude recorded at 7 different weather stations. The equation of least squares line is found to be what's there. When the numbers in this equation are correctly rounded to 3 significant figures. Now remember, there is a difference between significant figures and decimal places. They are not interchangeable. All right. What we need to do is we need to find the first important number in each thing here. So in this case, it's 42.9842. And in this case, the 4 is important, so we're going to keep that number. The 2 is therefore also important. The third number is this 9. But if we want to round everything off to that significant figure, we have to look at the 4th number. Is that more or less than 5? Well, it's more than 5 because it's 8. Therefore, we round everything up. Therefore, our answer either is C or E straight away. And then for the second number, 1, 2. So that 0 is not significant. We don't have to write it, but we usually do because it just helps keep everything in order. Decimal point, 877. So the 877 are our 3 significant figures. The 4th significant figure is a 4, which means we round down. Therefore, we just drop it off. And therefore, that is our only combination that works. Question 10. The coefficient of determination. So now remember, 9 and 10 are both linked. 9 and 10 are both linked. The coefficient of determination was calculated to be 0.983743. The coefficient of determination. What is the symbol that we use for that? What is the little nomenclature that we use when we talk about the coefficient of determination? That's the coefficient of correlation. What is the coefficient of determination? Thank you, R squared. So, R squared was calculated to be 0.893743. The value of the correlation coefficient rounded to 3 decimal places. So this is actually the first question that actually stumped more than half of the people here. You are wrong. What you need to do is remember that least squares regression line. Is that positive or negative? It is a negative line. That means that when we talk about the correlation coefficient, because that line is negative, therefore its R value must also be negative. Now, when you do this question on your CAS, and this is where a lot of people made the same mistake, is that they literally just went square root They literally just did that. Convert it to a decimal, and they get 0.94. But anyone here do methods or did methods? What is it about square roots that's interesting? They are positive and negative. So instead, when you do it with that button there, it just takes the positive square root. However, if we do it like this, if we say that r squared is equal to 0.893743, and we tell it to solve for r, would you look at that? I get 2 answers. I get a positive and a negative. And that way I can go, well, clearly because it is a negative line, I need a negative R value. So only 41% of people got that right because they relied too much on literally what their calculator says. All right, it is the one thing that these calculators can't do automatically. You have to specifically request it. And the way I've shown you how to do it here by doing r squared equals something, solve for r, that makes it do the plus or minus. And then you can solve from there. All right, it is indeed A. 41% of people got that one right. 46% of people did that. All right, so that one definitely separated a lot of people out. Let's move on. Question 11. A study was conducted to investigate the effects of drinking coffee. Coffee. In this study, the amount of sleep in hours and the amount of coffee drunk on is given this way. Interpret that data. All right. Interpreting the data. On average, for every additional cup of coffee drunk, the amount of sleep did what? All right. No, it is not B. All right. Now, clearly, yes, it is decreasing, but we can't take that for granted. All right. Remember, the correlation coefficient does not control the gradient. Well, it does not replace the gradient. The correlation coefficient shows how closely linked things are, but that doesn't mean that they are explicitly connected. So, it's not D, it's not E. What we need to do is we need to go and we need to find all right. There is actually an equation that we need to remember. The equation for the slope of a line. So B, so if remember we're thinking about A plus BX. B is equal to R, the standard deviation of the response variable, divided by the standard deviation of the explanatory variable. Right. This one you may have not used before. I don't believe it was on the SAC. However, this is how you would answer that question. You would take, so SR, response variable, is going to be that. The explanatory variable is that. You're going to put all three things into your CAS. So obviously, the more coffee you drink, the less you sleep. Oh, yes, SY, S. Yeah. So I think about it in terms of S response, S explanatory. Sorry. So in this case here, this is SY and this is SX. So on our CAS, do it quickly on our CAS. So that's negative 0.77. A reminder that if you need to put a negative symbol in, you've got on the if you go on the keyboard all the way down to the bottom, there's the number there. Otherwise, it keeps trying to put in answer. That's for the emulator anyway. 0.770 times, and then we put the fraction in 1.12, 1.56. And again, you can make sure that your CAS gives everything as a fraction by leaving it in standard, but if you want it in decimal, there it is there. So a lot of you had a swing and a miss, and it was indeed A. So I would be putting that somewhere safe in your brain. Actually, I know it's there. That formula is on the back page in the formula sheet. So you'll have access to it. Only 37% of people got that question right. All right. 31% went straight for B. 26% went straight for C. Only 6% of people thought it actually increased. Those people have clearly never drunk coffee. Question 12. Table below shows the value of two variables, x and y. The associated scatter plot is also shown. X is the explanatory. The scatter plot is non-linear. A squared transformation applied to the variable can be used to linearize the scatter plot. The equation of least squares line fitted to the linearized data is closest to. Again, there is no real way that you're going to just futz your way around and guess this. You have to do it on your CAS. You just have to do this. So, break out our CAS statistics, get rid of our old thing. We don't need that anymore. Now, in here, list 1, I'm going to put all my X values. 1, 3, 5, 7, 9, 11, 13, 15, 16 for some reason, 17, and 18. Have I got 11 data points? Yes, I do. And then I go through and I put in the correct pairs. All right, I've got my data there. I'm going to set that as a scatter plot, and I'm going to draw the scatter plot just quickly. Does my scatter plot look like the one on the page? Yeah. Looks pretty good. So, what are we going to do to it? A squared transformation applied to X. So what we're going to do is we're going to go here, down to here into this cal thing. And we're going to go list 1 squared. All right, and it's going to go onto our CAS and it's going to put all of these numbers in as squared numbers. I'm going to redraw, and instead of list 1 being my X list, list 3 will be my next one. And now if I draw that scatter plot, it's a little better. Now, it not perfect system. What we can now do, calc regression, linear regression, list 3, list 2, and we get those numbers there. Which of those answers best lines up with what's there on my screen? Why B though? Because you're correct, but why B? Because I squared X. All right. What I have on my CAS is the regression line for the squared transformation. So it's already assuming that X is squared. However, if I wanted to give it for this thing here, as an approximation, I then have to put the squared back in myself. And that means that B is the only answer. And 57% of people got that one right. Time series graphs. Numbers, boring, skip, down to the graph, down to the question. What's the question actually asking, though? Both 3 median smoothing and 5 median smoothing are being considered for this data. Both of these methods result in the same smooth value for which day? So, well, let's scribble on our graph a little bit. So, if I look at these three points here, so day 1, day 2, day 3, where's the median? It's that one there. If I look at these 3, the median is there. If I look at these 3, the median will be there. These 3, the median will be up there. Here. 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 So I have a smooth line that looks a little bit like that. Let's go to 5. So day 1, day 2, day 3, day 4, day 5. I've got number here, number here, number here, number here. That's the middle one there. For the next 5, so 1, 2, 3, 4, 5. Sorry. About 40. Next one along, 1, 2, 3, 4, 5. It's going to be about there. Next one along, 1, 2, 3, 4, 5. Out there. And then the last one, 1, 2, 3, 4. There. So where do they line up? Question 13, they line up on day 7. Because both of our dots overlapped each other. A least squares regression line is fitted to the time series plot data above. The equation of the least squares regression line with the day number as the explanatory variable is closest to what? All right, the day number means that it is the explanatory, which means that what axis is it going to be on? What axis is our explanatory variable always on? It's always on our x. That means that what can't it be? Which ones can we cross out automatically? We can automatically knock out A and B. Least squares regression line with day number as the explanatory. So what we'll do, we need to get some data. We need to get some numbers out. So we will go back up here, clear out all this. We don't need this. We've got day 1, day 2, day 3, day 4. Calc, regression, linear regression, list 1, list 2, bang, there's our numbers. 28.5 for A and 1.77. So it's not C, it's E. Nice guess, but yeah, wrong. Time series plot shows the monthly rainfall at a weather station in millimeters for each month in 2017. Speaking of rain, how did I put the numbers for the y-axis? That is an excellent question. So what I did was I went, so looking at the going back to the previous question, I entered those numbers along the top here. These were my x-axis. So these I put in list 1 in order. And then these ones here were my y values, which I put in list 2. All right, time series plot shows monthly rainfall. Speaking of which, it's raining outside. Thank you for joining me on this cold and rainy day. How very Melbourne. The median monthly rainfall for 2017 was closest to what? Now, you do not need to spend all your time entering this into your CAS and then calculating it, because you will probably not get the correct answer. So what you are looking for is there are 12 data points. There are 12 data points, and you are looking for data points that have roughly 6 above, 6 below. And in this case here, if I put a line roughly through the middle, I should get a situation where I will have a bunch of numbers above the line and a bunch of numbers below the line. In this case here, my red line with my ruler, which is kind of dodgy because I don't have a ruler, hashtag deal with it, means that it's come in around about the 100 mark, which is D. So it's a good instinct on that question there. All right. Remember, median means the same number above and the same number below, especially when you're talking about data points. And in this case here, if I draw a line precisely, I will have 6 above and 6 below. Now, you could take the value, though. Yes, you absolutely could. The problem is that you would then have to somehow read that graph, put it into your calculator in time, and make sure that your values are correct. If you enter those calculations wrong, July and September plus 2, but then you would still have to recognize that July and September are the two most middle ones. All right, my method has you doing it without any actual calculations. Draw a line 6 above, 6 below. Where is that closest to? So if you were to take July and September, yeah, look, it's going to be easy for some people, not so easy for others. But yes, you would probably find that the data point 6 and data point 7, in terms of if you were to sort them in order, would be around about there. But even then, that's about 97, that's about 110. Well, what's halfway between 97 and 110? 103. If 7 mean smoothing was used to smooth this time series plot, how many smooth data points would you have? If you were to 7 mean smooth, how many data points would you have? You would only have 6. Right? Because if I grab 1, 2, 3, 4, first things first, that. If I grab 1, 2, 3, 4, 5, 6, 7. So I've got 7 there. And then I grab the next 7, and I grab the next 7, and then I grab the next 7, and I grab the next 7. Yeah. I'm only going to have 6 circles of groups. One, 2, 3, 4, 5, 6, 7. Three, 4, 5, 6. So I can keep going through, circling, circling, circling. All right. Recursion and financial modeling. Yeah. Everyone's so happy. The value of A3 in this sequence generated by the recursion relation is given by what? So, A0 is 3. So, A1 is going to be 0 plus 1. Yep. So 2 times 3 is 6 plus 4 is 10. A2 is going to be 24. A3 is going to be D, because it's going to be 2 times 24 plus 4. They don't care what it actually is, they just want you to know how to work it out. Value of a compound interest investment in dollars. 17, by the way, 68% of people got that one right. Question 18. Compound interest investment after n years can be modeled by the recurrence relationship. Blah. The interest rate for this investment is what? All right. Remember that 1.0 is your initial investment. So that 0.01 is 1%. Done. Nice and easy. Jeff purchased a computer for $4,500. Good on you, Jeff. He will depreciate the value of his computer by a flat rate of 10% of the purchase price per annum. That's not how I depreciate a computer, but that's beside the point. A recurrence relationship that Jeff can use to determine the value of the computer after n years. It is a flat rate depreciation. All right? Because it is flat rate, that means it's going to be consistently the same amount each and every time. So it's not 10% of the previous year, it is 10% of the initial purchase price. So looking quickly through our options here, this one here has it increasing in value, so it can't be that. These two here have it growing based on, or growing or shrinking based on the previous year, therefore can't be that. V0, I don't know what's going on here. It's got some growth, it's got some things, so it can't be that. Therefore, A is the only answer. Without even doing any math, I've already eliminated 4 options based purely on what I know about the question. And in this case, 10% of 4,500 is indeed 450. Therefore, every year it's going down by 450. Ooh. amortization table. The annual interest rate for this loan is 3.6%. The interest is calculated immediately before each payment. For this loan, the repayments are made how frequently? So, what we need to do is we need to figure out that interest. We need to figure out the interest that is being paid as a percentage of the balance. So in this case here, let's go to our CAS. 900 divided by 300,000 is that. So 3 over 1,000. But how does that connect to what we've already got? How do I turn? So that's 0.003. The annual interest rate is 3.6. What can I multiply that by to try and get to something that involves a 3.6? .036 is the same as 3.6%. Therefore, 12. Which of those time units uses 12? Monthly. Done. So interest divided by the balance, and then figure out how that connects to 3.6. So what you could have done was 3.6 divided by 0.003, or 3.6. Yeah. Goal is to get to 12. Sorry. Yep. Oh, right. Yep. 0.036. There, 12. So 0.36 turn it into 3.6 turn it into a decimal 0.036, and then divide that by the number that you got to get the number of the frequency of those payments. Question 21, nearly finished. Yeah, you can use any combination of the numbers, as long as you're using an interest rate and the balance of the previous payment. All right. Compound interest investment. After n compounding periods, the coordinates of where n are 2 are 2b. What is the value of b? Ooh. That'd be a good question. How would you do it? How would you think about it? This is where I would start. I would look at Those two. You've gone from 500 to 580. So what sort of increase is that? So that's 16%. So if I do 500 times 1.16, and then I do ANS times 1.16, if I just compare my numbers here to the numbers that are on the paper, I've generated the other numbers, haven't I? Therefore, this number that I've got here in the middle here must therefore be correct. Yes. If you can figure out the connection between two different numbers and you're trying to fit a pattern, then you can fill in the pattern. Now, I would use these two for most accuracy because there's 0, 0, there's no decimal points. As with compound interest, as you start doing compound interest on decimals, then things start getting weird, and then everything, as you can see there with mine, it got weirder and weirder and weirder and weirder. All right. What I did is I needed to figure out the interest growth between this one here and this one here. So in this case here, I took the 580 and I divided it by 500. Correct. 580 divided by 500 gives me a value of 1.16. Now that 1 represents the original amount. The 0.16 is my interest rate. Now what I did to prove or to show you what was going on was I multiplied recursively that 1.16. And it turns out that when I do 500 by 1.16, I get 580. If I multiply 580 by the 1.16, I get this value here. But if I multiply that value there by 1.16 again, I get this fourth point. And if I multiply the fourth point by 1.16, I get the fifth point. Therefore, the point that I've got in the middle there, that 672.8, is the only one that makes sense. So think about it like this. What percentage of growth had to happen to go from here to here? Then apply that same percentage growth from here to here. That's 2 C's in a row again. Only half of the people who did that question got that question right. We are now at the part where people are actually starting to not answer questions. Question 22. A machine is purchased for $30,000. It produces 24,000 items each year. The value of the machine is calculated by... Yes, I know I can't see it. Is calculated by the unit cost method of depreciation. After 3 years, the value of the machine is that much. It is the unit cost. It produces that many units. A rule for the value of the machine is going to be what? So the first things first, how many units has it made? If it's making 24,000 units a year, how many will it have made after 3 years? it will have made 72,000. So I have two data points, 0, 30,000, and I have 3,72,000. So when if I've made no units, it's 30,000. But after I made 72,000 units, it is 18,480. We can take that onto our CAS. So if I've made 0 units, it's worth $30,000. If I've made 72,000 units, it is worth 18,480. Calc, regress, linear regression. And then you've got A plus BX there. The only one that makes sense is E. Thank you. 53% of people got that one right. Joseph borrowed $50,000 to buy a new car. The interest on this loan charged at 7.5% per annum, compounding monthly. Joseph will fully repay this loan with 60 payments. Immediately after the 59th repayment is made, Joe still owes that much money, the value of his final payment. This is a question for Mr. Financial Solver. Because it's clearly not going to be him just paying off that last little bit. There's a little bit extra that he has to pay on top. So, menu, financial, compound interest. So, it's compounding monthly, 12 and 12. Final value, what's the final value? Obviously, you want the final value to be 0. N will be 60. The interest rate will be 7.5. And the initial is 50,000. Now, by doing it that way, we have actually got a slightly incorrect answer. Because what we've done is we have worked out the payment that needs to be made for the entirety of the loan. What we only care about is that last month. 1 month, 7.5%. How much does he still owe? 995.49. And now we press that one and we get $1,001.71. And that is how much he actually is owed. All right, so they've given you all this extra information that you don't need. But one of the answers that they put in there was if you did take advantage of all that extra information. You care about this information, you care about this information. You know it compounds monthly, so you need that for PY and CY. Final repayment. How many payments does he need to make? Well, 59th, 60th, so he needs to make one payment. And the last question of the multiple choice. Millie invested $20,000 in an account with her bank, interest compounding monthly. After 1 year, the balance was that. The difference between the rate of interest per annum used by her bank and the effective annual interest rate was... So we're talking about rate of interest used by her bank and then her effective interest rate. So if we go into our CAS and we financial solver, compounding monthly after a year, so that's 12 months. The interest rate we don't know. We know the principal value was 20,000. After 1 year, well, payments made, we don't need to make any payments. Is it 20,000 or is it minus 20,000? This is an investment. All right. Remember, if we are giving money to the bank, it is negative 20,000 because we are giving them the money. We are not making any additional payments, and the final value is going to be 20,732. And now we can press and get our interest rate, which is 3.6. So the rate per interest and then we need the effective annual rate of interest. And the effective annual interest rate, it is not A. The effective rate of interest, there is a thing called R effective. Yeah. Is that bad boy there. So we put that, we've got that, this one here. We put that into our calculator. Bracket 1 plus fraction R, which is 3.6. 100 times 12. There's bracket in the power of 12 minus 1. and then I multiply that number by 100 to get the percentage. I get that, which is 3.66. 3.66 minus the 3.6 that we already started with, and we get 0.06, which is the answer. Sorry. Let's think about that one myself. But there is how you would do that. I realize that we're running a little bit behind schedule, so we're going to have to power through these. Question 1, matrices, how many of these are defined? Can I do that one? 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 I can only do 2 of these. I can only do that one, and I can only do that one. The others don't work, therefore the answer is 2. 2 rides called the Big Dipper and the Terror Train, costing dollars for the child to ride is on each one. 6 children ride only once on the Big Dipper and only once on the Terror Train. The total cost of the rides in dollars for these 6 children can be determined by which of the following matrices? The total cost of the rides. Which ones of those are doable? Which of these matrices are valid? Because they're not asking you to actually calculate anything. They're asking you which ones of these are defined. You can't do a 1 by 1 times a 2 by 1. Remember, rows, columns. D is the correct answer. Because you're going to get... Because remember, what's the resulting matrix going to be? That plus that. They don't match. Doesn't match. Well, that's a 1 by 2 by a 1 by 2. Therefore, they don't match. This here is a 2 by 1 times a 1 by 2. And that's going to create a 2 by 2, which we don't want. Oh, thank you, Miss Sawara.
You're welcome. And sorry, I do have to go now, but thank you very much,
Not a problem.
Mr. Dywell, and thank you everyone else. Bye.
Yeah. Whereas this one here will produce a 1, so that's a 1 by 2 times a 2 by 1, and it will produce a 1 by 1 answer, which is what we need. D is the only answer that makes sense. Consider the matrix. What is the matrix? The elements in matrix P are determined by the rule what? This is an example where row 1, row 2, column 1, column 2, column 3. This is pattern recognition. This is I don't like this sort of question because I don't think it actually does accomplish anything. But what they're doing is they are trying to get you to generate pieces of information about the matrix by using a rule. So in this case here, what we need to do is we need to just start trying them. It can't be A because A only uses J as a piece of information. It also therefore can't be B. So A and B are out straight away. We need to use both I and J in our equation to generate those numbers. I plus J plus 1 equals the value of that there. Well, if we go row 1, column 1, 1 plus 1 plus 1 is 3. Cool, that one, okay, so we're off to a good start. Row 1 plus column 2 plus 1 should equal 4, but it doesn't. Therefore, it can't be that. I plus 2j. Well, row 1 plus 2 times column 1 is 3. Cool, that's correct. Let's try the next one. Row 1 plus 2 times column 2. That's 5. So, can't be that one. But, because we've eliminated all of those, therefore the only answer left is E, which it happens to be. And you can go through and you can check. If I go row 2, so I is 2, so that's 2 times 2 minus column 1, which is 1 plus 2. 2 times 2 is 4 minus 1 is 3. 3 plus 2 is 5. 2 times 2 minus 2 plus 2 is indeed 4. And 2 times 2 minus 3 plus 2 is indeed 3. So E is the only one that makes sense for that one. Stella completed a multiple choice test that had 10 questions. Each question had 5 possible answers, A, B, C, D, and E. For question number 1, Stella chose the question E. Stella chose her remaining answers based on that transition matrix. All right, no technology needed for this one. But she followed a pattern. If she picked question E for the first one, looking at the state matrix, this question, E, what did she pick next? C. If she picked C, what did she pick next? A. So that's question 1, question 2, 3, 4, 5, and 6. If you picked question A, which one do you pick next? You pick D. If you picked question D, you picked B next. If you picked question B, you picked E, and then the whole process starts again. Question 5. Which of the following systems of simultaneous linear equations best represents the matrix equation above? Oh boy. So let's just quickly go through and see if we can find any that are complete nonsense. So all of our answers are the same, therefore we can't rule any out just by the way the answers are laid out. So let's look here. This one here, that's going to be 2v plus 2w minus 2x plus no y's. 2v, 2w's minus 2x's, therefore it can't be that one. 2v's, 2w's minus 2x's, so that one's okay for now. We'll need to check the others. 2v's, 2w's minus 2x's, okay. So, well, surprisingly, all 4 of those are still okay. So we move on to the next row. 0v plus 2w. So 0v. So if there's any of these that have got a 0v in that third row, well, can't be that. 0v plus 2w. Yep. Plus 2x minus 2y. Cool. That's okay, that one's okay, and that one's okay. Next one. 2v plus 0w minus 2x. Oh, can't be that one. So we're down to B and C. Go to the first one. 2v plus 2w plus 2y. Nope, can't be that one, therefore it's B. A water park is open from 9 until 5. There are 3 activities: the pool, the slide, the water jets. Children have been found to change their activity each half an hour as shown on the transition matrix. A group of children has come to the water park for the whole day. The percentage of children expected to be at the slide at closing time. Jeez. Okay. All right. The best thing I think to do for that one there is to take this transition matrix and raise it to a power. All right, this is long-term explanation. The number of... We don't need to know an initial state for this one. This is just a long-term expectation. If I take that transition matrix and I raise it to a power, particularly how many half an hours is there between 9 and 5? So how many times will that transition matrix actually be applied? All right, 8 hours. So it's 16. So if I go and I create this matrix on my CAS, 0.8, 0.2, 0.4, 0.05, 0.6, 0.1, 0.15, 0.20, and 0.5, and I raise that to the power of 16, I have this information, I have this gargantuan matrix here, which is not useful in the slightest. However, the number of kids at the slide. The number at the slide currently. $30.138, which is 14%. Because if I apply this state matrix enough times, what have I reached? What's the state that I've reached? What's not really changing? All right, it's an example of steady state. Just shrink that down. You can see there, 0.1379, which is 14%. Communication matrix. Sender, receiver. The one means that person can send it. How many ways can Y get a message to W by sending it to only one other person? W can only receive messages from U, V, and Y. And Y can't actually message U and V. Therefore, this is a trick question and it's 0. All right. The receiver W can only get them from these 3 here. To one other person. Other. Other is the important bit there, Bastella. All right. Y can send directly to W, no problem. But the question is, how many ways can Y get a message to W directly through another person? And through another person, that answer is 0. An airline parks all of its planes at Melbourne or Sydney Airport overnight. No one's going anywhere these days. A transition diagram shows the change below from night to night. There are always M planes parked at Melbourne and S planes always parked at Sydney. Of the planes parked at Melbourne on Tuesday night, 12 had been parked at Sydney on Monday night. How many planes does the airline have? So 0.48 of the Sydney planes is 12. So what's 0.48 times, so 12, 0.48. So what is 12 divided by 0.48? Divided by 0.48 is 25. So already we have to have a minimum of 25. As the numbers stay the same at each location, they must also send 12 planes from Melbourne to Sydney. So what is 12 divided by 0.2? Therefore, what is 60 plus 25? Which is the answer. I just realized the CAS has moved itself. All right. We are nearly finished. We've got 3 more pages to go. Graph below shows the water level in a creek over a 12-hour period. Compared to the water level at 8 a.m., the water level at noon was closest to how much higher? head to 8 a.m. At 8 a.m., the water was here. At noon, it was here. How much difference is that? 1.4. That's the closest answer. The cost C of using kilowatt hours of electricity is calculated by the equation below. From this equation, 52 plus 0.15 times K, how do we describe that? First things first, this here is a fixed charge of $52. Therefore, that one's gone, that one's gone, that one's gone. 0.15 times the number of kilowatt hours. 0.15 or 15. 15 per kilowatt hour. No, that one's gone. Therefore, it's D. A shop sells two types of discs, compact discs and DVDs. CDs are sold for $7 and DVDs are sold for $13. She bought a total of 16 discs. How many DVDs did she buy? So this is a simultaneous equations question. So X is CDs, Y are DVDs. X plus Y equals 16. And 7X plus 13Y is equal to 178. Calculator. X plus Y equals 16. 7X plus 13Y equals 178. X comma Y. X is 5, Y is 11. The question says how many DVDs did she buy? What of those numbers represents my DVD count? That's 11. Moving on. The graph shows a straight line that crosses the axis at -10, 0 and passes through -6, 8 and crosses at 0, Q. What is the value of Q going to be? All right, this is a gradient question. You've gone from here to here. So you've gone 4 across and 2 up. Therefore, if we go another 4 across and 2 up, that puts us at -2. 4 across and 8 up, sorry. 4 across, 8 up, 16. 4 across and 8 up puts that at 20. Which is D. So you can just logic that one. You could, on your CAS, do this instead. Menu statistics -10, 0. Or do the other point of -6. And 8. Calc regression, linear regression. And it gives you the answer A is 20, which is what we already worked it out to be. All right. Giovanni makes and sells toy train sets. I thought he mostly led Team Rocket. Each toy train set costs $40 and sells for $65 as a fixed cost for making a batch of toy trains. Last Sunday, Giovanni sold a batch of 35 toys. What is his fixed cost? So, if he sold 35 times 65, how much money did he make? Well, he sold $2,275 worth of stuff. But what we know is we also know that 35 times 40 is the total cost of making the train sets on a unit cost basis. That is $1,400. Plus his fixed cost. We know that he made $250 of profit. So we have this equation here. So 250 minus equals 2275 minus the 1,400 minus the fixed cost. And that fixed cost is $625. So no matter how many he makes, there's always that minimum cost that he has to put in to make his train sets. So 2275 minus 14 is 1875. 875 minus the 250, 625. So that's B. Question 6. Recipe for a fruit drink lists pineapple and mango juice. This question looks familiar. For every 200 milliliters of mango juice that is used, 300 milliliters must also be used. At least. X is pineapple, Y is mango. So what we can do is we can define it like this. X over Y at least needs to be in a ratio of 300 over 200. Oh, at least. If I simplify that ratio down, what do I get? Well, I can automatically knock off the zeros. And if I multiply, if I take that Y and I times both sides by it, I get X 3Y over 2. Now, small problem is that this doesn't match any of these because that's the wrong way around and it's upside down. That's the wrong way around. But one of these will have to be equivalent. If I take the 2 up, I get 2x, 3y. If I take the 3 down, 2x over 3 greater than or equal to y. And then I can just flip that y. So the answer is C. %37% of people got that question right. These were the parts that a lot of people made mistakes on. All right. You can't just swap the x and the y around. You have to flip all the numbers that go with them, because remember, those numbers are bound to those pronumerals. The feasible region is here. The equation of the objective function is of the form mx plus ny. The dotted line passing through V and W in the diagram has the same slope as the objective function for this problem. All right. Here's what I want you to think about. What's the gradient between here and here? So what's that? Now it says the same slope as the objective function for this problem. What about here to here? So that's -3. That's -3. What about from here to here? It's the same. It's -3. What this tells me is that if I'm trying to minimize, that I'm trying to use the smallest numbers possible. And as long as so if I use these numbers, they're quite big. If I use these numbers, they're still quite big. But if I use any number along this line here, they're going to be the smallest possible, because everything's got the same gradient. Therefore, E is the only answer that makes sense. Now, that one's a tricky one. 47% of people got that one. All right. It's a doozy. So I had to think about that one myself to get to the point where I could just, logic it out and go, well, if it's anywhere on this line, provided it's within the shaded area, of course, then I can work with it. All right. Last question, and that should take us right through to 1:30. I'm sorry that I didn't get through to the second exam. I will record something for that for you all. Anyway, Jenny and Alan's home at 900 from a supermarket. Jenny is at the house. Alan is at the supermarket. At the same time, Alan leaves the supermarket, walks towards the house. We therefore have a piecewise function for Jenny walking at very strange and weird speeds. More power to her. J is the distance in meters from the house after 10 minutes. Alan's planned walk is modeled by that, A. A is distance in meters from the house after 10 minutes. So in this case here, Jenny is walking like on a variable thing, whereas Alan is walking at a consistent speed towards the house. Where will they meet? So I think the easiest thing to do is to actually just graph this damn thing. So now remember, you can graph piecewise functions on your CAS. Under Math 3, third row, fourth column, you get that. We need 3 pieces of information for this one. T is going to be represented by X in this. Make sure that when you are putting these into your CAS calculator, you are using the correct inequality symbols. And 65x plus 250. 6x 10. And then the last one in the other equation in red, we'll put Alan. And we will draw the graph. Obviously, we can't see anything, so we need to change our window. 0 to let's go 10. I mean 0 to 900. Ah, look at that. There we go. So, where do they cross over? Analysis, GSolve, intersection. 4.77777777. So that means it's going to be something over 9. So 0.77 is 7 over 9. So it's 36 plus 7 over 9. So it's 43 over 9. So T equals 43 over 9, which is 4.777777. Is it D? No, it is not D. Okay, so what we're going to do is we now have this 4.777 thing. Now, because Jenny's is piecewise, we are not going to use Jenny's to help us do this thing. So, according to this, on the CAS, remember that which direction is Alan walking? Alan is walking to the house. Alan is walking towards the house. And what his equation means is that he is from the house. So he's walking towards the house. That means that at this time, he is 518 from the house. Where did he start, though? He started 900 from the house. So how much has he changed? Well, that's 900 minus 518, which is 382, which is C, the answer.